Hi, in this video we're going to find the length of a space diagonal of a prism. And by space diagonal, I mean a diagonal inside the 3D shape. So let's just draw it out. We want to find the length of QC. And it's called a space diagonal because it's inside the shape. If the diagonal was on a face of the 3D shape, it'd be known as a face diagonal, but it's a space diagonal because it's inside. Right, how do we find that length? Now, we saw that the key with all these 3D Pythagoras problems is to identify a triangle, a 2D triangle, that we can then use Pythagoras on. Now, if I was to add an extra length from here to here, Q to O, can you then see that if I include OC as well, we've then got a right angle triangle. Look, this is a right angle triangle here. This is a right angle triangle where the right angle is here between these two lengths. Let's just make that black just for clarity. There we go, that's better. Okay, right, we're trying to find the length of QC. Now, we've already got one length for this yellow triangle. We know the 12, but we don't know OQ. But we could work out OQ by using this right angle triangle at the bottom. Can you see OAQ? That is a right angle triangle. So let's draw out OAQ separately, like this. This is OAQ. And we've got the 6 here, we've got the 7. And let's call this length OQ, let's call it X, because we don't know what it is, we're going to call it X. Now remember how Pythagoras theorem works. If we label the shorter sides of this triangle as A and B, either way round, and the hypotenuse, the longest side of the right angle triangle, as C, which is always opposite the right angle, then Pythagoras theorem is that A squared plus B squared is equal to C squared. So let's substitute in the values. A is 7, so 7 squared. B is 6, and C we said was X. Now what is 7 squared plus 6 squared? 49 plus 36 is 85. So X squared is 85, and therefore X is a square root of 85. The square root cancels out that squared. So we know this length down here is root 85. Let's write it here. And I'm going to leave it as a square root of 85 rather than as a decimal. There's a good reason for it, which we'll see in a second. Now, let's focus now on the yellow triangle. The one we did before was the purple one. So now we're going to do the yellow one. So we draw it out. Shade it in yellow. And so let's look at the lengths. We've got the 12 on the left. And the bottom length is OQ, which is root 85. And we're trying to find this blue length here, CQ. Let's just call it Y, because we've already used X. So let's make that Y. And then Y will be the answer that we want. So let's use Pythagoras again. The two shorter lengths I'm going to make as A and B, either way around. And the hypotenuse is C. So A squared plus B squared equals C squared. So A is 12, so 12 squared plus the B squared, which is root 85 squared, is equal to the C squared, Y squared. Now, 12 squared is 144. Root 85 squared, well, this squared cancels out the square root, leaving just 85. That's why we left the root 85 as root 85 rather than as a decimal. That's equal to Y squared. Now, what's 144 plus 85? It's 229. And then we square root both sides, so Y is root 229, which as a decimal is equal to 15 point, how many decimal places? 1 decimal place, so 15.1 centimetres. So that's the answer. QC is 15.1 centimetres, and we're done.